Okay, here is a little known identity that will help us solve this equation without actually using a graphing calculator. It's true that the cosine cubed of x is equal to 3/4 cosine of x plus 1/4 cosine of 3x. Not going to bother showing how to prove that identity right now, but here's sort of some proof using the Desmos graphing calculator that indeed the graphs of these two functions are the same. Y equals cosine cubed of x and y equals this expression result in the same graph in the Desmos graphing calculator. So given that, let's see what happens if we substitute this into the given equation for cosine cubed of x. So I'll do that over here. 8. I'm going to replace cosine cubed with its identical expression, 3/4 cosine of x plus 1/4 cosine of 3x then minus 6 cosine x minus 1 equals 0. When I distribute the 8, I get 6 cosine x plus 2 cosine 3x minus 6 cosine x minus 1 equals 0. Conveniently, the 6 cosine x's drop out. And I've got 2 cosine 3x equals 1. So the cosine of 3x, I'll put the 3x in parentheses for emphasis, equals 1/2. So 3x is equal to the inverse cosine of 1/2. Of course, there's infinitely many angles that have a cosine of 1/2. One of those, if we think about the 30, 60, 90 right triangle, 30, 60, 1, 2, radical 3, we see that 3x can be 60 degrees. That's an angle that has a cosine of 1/2, or pi over 3. But then we can start listing some other angles that have a cosine of 1/2, including, well, if I go into the fourth quadrant, where I've gone around this way, 2 pi, take away pi over 3, is 5 pi over 3. And then I could keep going around and around. 2 pi, add 2 pi to each of these as many times as I want, or as a matter of fact, subtract 2 pi as many times as I want. So we could actually, since it doesn't restrict the domain here, there's infinitely many solutions to this problem. But I'll just show you that if I divide every term over here by 3, I start to get expressions that look like this. And you can come up with a formula for all of these 3x's where we say, let's say, let k equal a subset of the set of integers. I'm not going to go into that here. I'll let you figure that out. Okay, but that's the most straightforward way to solve this problem.